Hi everyone. So today we're doing Algebra 1, Lesson 2-3. So we're going to be talking about graphing linear equations using intercepts. So intercepts are points on the graph that are kind of easy to find and easy to identify. And so we're going to look at how we can use those to our advantage. We're also going to talk about a couple of other things just in terms of being able to tell whether an equation is a linear equation or not, and then also talk about another form of a linear equation called the standard form. Our goal today is to be able to find the intercepts of a linear equation, and our essential question is, what are intercepts, and then how can we use them to help us graph linear equations? Okay, so the first thing we've been talking about here is the slope-intercept form, right? The y equals mx plus b, and we talked about yesterday how the m represents the steepness of a line, right? Whether it's very flat or very steep. We also call that the slope, and then the b talks about the y-intercept, right? The b is the y-intercept, and so we've already had some exposure to intercepts. Our b value represents where the line crosses the y-axis, okay? And sometimes that's written just as a number. So we would say, b equals 4, which means it crosses the y-axis at the point 0, 4. And sometimes we talk about that b as a coordinate. So we would say the y-intercept is 0, 4, right? The problem is that sometimes we're not given the equations in this form, right? Like it's nice when we are, but we're not always given that. And so we want to be able to first of all, be able to tell just by looking at an equation, first of all, is it linear, right? Will this make a straight line if I graph it, right? Can I put it in the form of y equals mx plus b? And so, we might see equations that look like this. Or, we could even see equations that look, like this, right? And they could be, even kind of, more messed up, I guess you'd say, than this, right? They could be all kinds of crazy things. You may have to do a lot of cleaning up, a lot of, distributing and combining like terms and moving things around before you can actually get it into the slope-intercept form. But I'd like to know just by looking at an equation if it's linear or not. And so there's a simple way to do that. And so what we do is we look at first of all, we look at the variables. Okay. So if we have a variable and the variable has an exponent, that's not 1. All right. Now when we talk about exponents, a lot of times if the exponent is 1, we don't write it. So this is y to the first power, x to the first power, right? Anytime we have a variable and it's just raised to the first power, that's our first clue. Okay, so if we only have exponents of 1 or something raised to the first power, that's our first clue. The second is that there can't be any variables in the denominator of a fraction. Okay, in the denominator of a fraction. So what do I mean by that? I mean by like over here. So if I have 3 divided by x, x would be in the denominator of a fraction. Or if I have something like 1 over y or x over y, those can't happen in a linear equation, right? Those things make it non-linear. They actually make it like curved and things like that. So, so that's the other thing we're looking for. So we're looking for variables that that have an exponent of 1, and we're looking for variables that are by themselves, right? They're not in the denominator of a fraction. And the last thing is we can't multiply variables together. So this talks about, like, if I have, for example, this one over here, 3x times y. Well, x times y, I can't multiply those variables together and have it be linear. All right, I can multiply those variables together, but it won't be linear. So I'm trying to figure out if it's linear. So if I look at that and I see, well, there's some variables that are multiplied together, that's not linear. If I look at this one here, I have a y squared. I have an exponent other than 1. That's not linear. Here I have an x variable, that's not 1. This is x squared. That's not linear. Here I'm dividing by y. I have a y in the denominator of this fraction. That's not going to be linear. And here I have an x in the denominator of a fraction. That's not going to be linear. So if it meets all these criteria, if it has just the variables, right? The variables are raised to the first power, have an exponent of 1, and we don't have any variables in the denominator of a fraction, and we don't multiply any variables together, then we would say that's linear. Okay. Sometimes we'll talk about that as a degree 1, right? That just means the exponents are all 1. So we call that a degree 1 or first degree equation, but more commonly we call those a linear equation. Right? So that's an easy way to check to see if an equation is linear. The other thing that we'll see is every kind of equation has what's called a standard form, and the standard form is kind of the official way of writing that equation. It's not always the most useful, but it kind of follows a particular formatting thing, so it's easy to kind of identify them and classify them and so forth. The standard form, all the variables are on one side, on the left side here. Okay, all the variables are on the left-hand side, and the constant term, right, the one without the variable, is on the right-hand side. So, and then the other thing is that they go in order. So I have x comes first, and then y comes second. A and B here A, B, and C are just some numbers, right? Whatever some numbers. They're the coefficients, the numbers we're multiplying by those variables. And in standard form, that very first variable has to be positive. Okay, it has to be positive, and all three of these numbers have to be integers. So if it has a decimal or if it has a fraction, it doesn't mean that it's not linear. It just means that it's not in standard form. Okay? So we're kind of looking for all these things, and it's very picky about that. If any one of these things is off, we'd say that's non-standard form. So it's kind of a technicality, and we're not going to spend a whole lot of time on it, but you will be asked to write things in standard form, and so we just want to know what that is, and to be able to do that. So let's look at an example here. First of all, we want to look at this equation, and it's asking, is this linear? And so I'm going to look at this and say, well, this is y to the first power, and it's x to the first power. I don't have anything, to a squared or a square root or, anything like that. I'm not multiplying variables together, and I'm not dividing by a variable. I don't have a variable in the denominator of a fraction. So it meets those three criteria, so I would say this is linear. So I would say that's linear. I can also tell, because that particular one is written in slope-intercept form, y equals mx plus b. And if it's written in that slope-intercept form, right, that's another quick way of telling it's linear. Slope-intercept form, this is slope, this is the y-intercept. I know that that's linear. So it is, so they're asking us to write it in standard form. So standard form has all the variables on the left-hand side, and the constant term is on the right-hand side. So this doesn't have that. My variable term is on the right-hand side. So I want to move this variable over to this side. And so the way that I'm going to do that is I'm just going to do like we always do in equations, right? When we're trying to move things around, I'm just going to add the opposite. I have a positive 3x here, so I'm going to add a negative 3x here. And I got to do it to both sides. So now when I combine these together, I get negative 3x plus y equals negative 4. So let's check again. Is it in standard form? Well, I have the variables on the left-hand side, right? I have them in order. I have the x variable first and the y variable second. I've got the constant term all by itself on the right-hand side. Okay. The numbers here are integers. Okay, so the integers. I don't have fractions or decimals or anything like that. So that's good. The only thing that's an issue is this very first term, this a value right here. This should be positive. And right now I've got a negative 3 in front of that, and I'd like that to be a positive. And so what I'm going to do, and this is just kind of a standard sort of math trick, is if I want to change the signs on everything, what I'm going to do is I'm going to multiply everything in this equation by negative 1. And I'm going to write this like this. I'm going to say the whole equation I'm going to multiply by negative 1. Okay, so this is negative 1 times negative 3x gives me positive 3x. negative 1 times positive y gives me negative y, and negative 1 times negative 4 gives me positive 4. And so you see that the end result is I just changed all the signs, right? I changed all the negatives to positives and all the positives to negatives. Now, I've got the variables on the left-hand side. They're in order. I don't have any fractions or decimals in here, so they're all integers. And my leading coefficient, my coefficient in the very first term, is a positive number. So this would be considered standard form. So let's talk a little bit about intercepts. Intercepts, the word intercept just simply means to when things meet or where they cross or where they come together, right? And so when we talk about intercepts, that's what we're talking about. We're talking about where graphs cross certain things. So we can talk about where two lines, intersect each other or intercept each other. But in this case, we're talking about where they intercept the axes. So remember, we have the x-axis that runs along this way, the y-axis that runs along this way. And so what we want to find are these 2 points. The x-intercept is just simply where a graph touches the x-axis. So I'm just going to put a graph on here, a line on here, and let's make it red. And I'm going to put a line on here, and I'm going to put it like there. I like that line. Okay, so if I look at this line, right, if I look at the x-intercept is where it crosses the x-axis. So where it crosses the x-axis on this line is right here at 5. Sorry, at negative 5. It crosses the x-axis at negative 5. Okay? It crosses the x-axis at negative 5. So, so I would say my x-intercept here, my x-intercept is, my x-intercept for this red line is going to be negative 5, 0. Our x-intercepts are always going to have a y value of 0. That's just by definition. For it to sit on the x-axis, the y value has to be 0. So that's a really common thing to look for. I can tell an x-intercept because that y value is going to be 0. Now, if I look at the y-intercept is where it crosses the y-axis, right? And so I'm going to look and see where that happens, and that happens right here. Okay, right here. So that happens at the point 0, 6. So I would say my y-intercept here is 0, 6. Okay, so from a graph, it's really easy to find those intercepts. They're just the points where they cross, right? On a y-intercept, my x-coordinate is always going to be 0. And for an x-intercept, my y-coordinate is going to be 0. So that's an easy way to tell, and that's an easy way to calculate these as well, and we'll look at that here in a second. So here, it gives me a table of values, and it asks me to find the x and the y intercepts and to graph that. Now, I could graph each one of those 5 points and draw a line through it. Okay, that would be one way to do it. But I don't really need to graph all 5 points. To graph any line, all I need are 2 points. And so I'm going to take some easy points here. And so I notice that, look, right here, my x-coordinate is 0. My x-coordinate is 0. That means that this point right here is my y-intercept. This is my y-intercept. This is where it crosses the y-axis here at 0, 4. So it's going to cross right there. And likewise, I can see that this y value here is 0. So this is my x-intercept. This is my x-intercept. And so I can tell really quickly just from this graph, if I recognize, right, the properties of the x and the y-intercepts, those 0 values in the x and y, here's my x-intercept is at 2, 0. So that's going to go right there. So if I need to graph this line, that's an easy one to graph now, because I can just go through those 2 points. So there's my line. It should go through the point negative 1, 6. And so I can check that. Negative 1, 6. You can see my line's a little bit off. So I can fix that. Okay, so it should go through that point. And it should go through the point 1, 2. So you see I need to adjust my line a little bit. And then 3, negative 2, right? So it's going through all those points. So I can see that's a pretty good line, right? It's a pretty good graph of that line. But I didn't have to graph every single point. I didn't have to, do all 5 of these points. Just identifying the intercepts and graphing those. So here's another equation. This time they give us an equation, right, and not a line. And so, first of all, I just want to make sure it's linear, right? So if I look at this, I see all my variables have exponents of 1. Okay, all my variables have exponents of 1. I'm not multiplying variables together. I'm not dividing by a variable. I don't have a variable in the denominator. So I'm pretty sure this is a linear equation. And I also noticed that the x and y terms are on the left-hand side. My constant term is on the right-hand side. All of the numbers here are integers. Okay, they're not fractions or decimals or anything like that. And this very first coefficient, right, this first number out front here is positive. So this is actually in standard form. Okay, so this is this line written in standard form. All right. So again, that's a fairly common way you'll see those lines written. What we want to do though is we want to find the x and the y intercepts. Okay, now I don't have a graph, so I can't just look at it and see. I don't have a table of values, although I could build one. But I do know that whenever I have an x-intercept, that means the y coordinate there is 0. Okay, so if I replace y with 0, then I would have 4x plus 0, right, is equal to 2, and I could easily find my x. I divide both sides by 4, and I would get x is equal to 2 over 4, or 1/2. And so I can see that it crosses the x-axis at 1/2, at the point 1/2, 0. And so I don't have a mark there, but I can eyeball that pretty well. Okay, so here's my x-intercept is the point 1/2, 0. Now in your assignments, they're going to ask you to put these intercepts as a coordinate. So they want you to put the x and the y value in there. So we wouldn't say the x-intercept is 1/2. We would say the x-intercept is the point 1/2, 0. Likewise with the y-intercept, if I go to find the y-intercept, well, the y-intercept is where x is equal to 0. And so if I put 0 in for x here, I would have 4 times 0 would be 0, plus y is equal to 2. And so I can tell very simply, right, very easily that my y-intercept, it crosses the y-axis at 2. And so that's going to be the point 0, 2. 0, 2. So right here. And so I can go ahead and graph that line now. Make sure I go through those. I'm a little off there. This is not the best graphing application. There are much better ones, but I can see that's a pretty close. Okay, so there's my line, and I did that just by finding those 2 points. Okay, those points are easy to find. They're usually easy to calculate because when you plug in that 0, one of the variables just disappears, and it's pretty easy to solve that other one. That's partially why we do that. Find the x and y intercepts here. Again, I've got a line in standard form. So to find my x-intercept, remember, is where y is equal to 0. So if I plug 0 in for y here, this term goes to 0. So I would have 3x equals 12. And if I divide both sides by 3, I would get x is equal to 4. And so I'd have the point 4, 0. For my y-intercept, y-intercept is always where x is equal to 0. X, 0. And so if I put 0 in for x here, this 3x becomes 0. And so I would have negative 4y equals 12. And if I divide both sides by negative 4, I would get y is equal to negative 3. So my x-intercept, or sorry, my y-intercept would be 0, negative 3. So if I place those points, I have 4, 0, and 0, negative 3, and then I can draw that line through those points. Adjust that a little bit. Okay, so if you're graphing this on paper, you'd want to use a straight edge. Make sure you got a nice and straight line. For using, MyOpenMath, they make the graphing pretty easy in there, and so you just have to pick the points and it'll draw the line for you. Okay, so we're using those definitions of x and y intercepts, right? The fact that x-intercept, the y is 0, and for the y-intercept, the x value is 0. I'm using those definitions to help me calculate those points, and then I can graph that. Let's find the x and y intercepts of this equation here. So this is a special equation, right? We look at this. First of all, is it linear? It is. Even though there's no x variable in there, my y has an exponent of 1, and I'm not multiplying variables together. I'm not dividing by variables, and so we would say this is linear. But the x variable is not in this equation, and so we've looked at some of these yesterday, and I know that if I built a table of values, right, it wouldn't matter what my x variable was, right? If x was negative 1, I know that my y is going to be 3. It doesn't matter what my x variable is. My y value is always going to be 3. Okay? Now the problem here is that I can't set y to 0 because of the rule here, right? The equation says that y can't be 0. Y has to be 3. So I can see right here, I've got a y-intercept. I've got a y-intercept of 0, 3. But this line does not have an x-intercept. The x-intercept would be where the y value is 0, and the y value can't be 0. So the y-intercept here, the x-intercept here, right? It does not exist. So we would say in MyOpenMath, we would write D and E, does not exist. Okay, that is a horizontal line, and so if I were to graph that, right, if I put that y-intercept on there, right, I know that that's just going to be a horizontal line through that point 0, 3. And then likewise here, similar situation. It's still linear, right? I've got an exponent of 1 on here. I'm not multiplying variables together. I'm not dividing by variables. So this is linear. But we have the same situation here. This time, it doesn't matter what my y value is. My x value is always going to be negative 4. So it doesn't matter what y value I choose. It's always going to be negative 4 for x. Okay, so we have a similar situation here. Here I have my x-intercept. Right? This is my x-intercept, is where y is 0. So my x-intercept here would be negative 4, 0. But my y-intercept, where x is equal to 0, well, x can't be equal to 0. So my y-intercept does not exist in this case. Okay, my y-intercept does not exist. So to graph this one, I would just simply put it here, right? And I know that all my x values have to be negative 4, so it's going to be all these values here. So I'm just going to have a vertical line here through negative 4. Okay, I'm going to go ahead and end the lesson here. So take a look at the homework and see how you do.